Good morning to one and all present here. I, Vignesh A.R. of Perry Institute of Technology, welcome every one of you to the webinar. I welcome our chief guest, Mr. Vignesh R., Technical Coordinator, Access Global Automation Group of Companies. He is having wide experience in the automation environment and he given 250 plus seminars and guest lecturers on industrial automation. Welcome, sir. After the knowledge sharing session, there will be a question and answer session. There, our chief guest will answer your questions. So, all the participants are requested to mute the microphone and also turn off your camera. Your cooperation is highly expected. Thank you. The program will start within few minutes.
Thank you for the warm welcome, sir. Hello, guys. Good morning. Good morning, everyone. So this is Vignesh from Access Global Group of Companies. So before getting into our session about robotic process automation and its future, what we are going to see about is let me give you a brief introduction about our company first. Okay. So who we are? We are automation solution providers for and robotic solution providers for many industries. Uh, and we are specialized in application development, turnkey projects, retrofitting, upgrading of old machine control system, control panel manufacturing, and robotics installation and commissioning process. And we have four division. Access Global Automation is our parental company, where we used to deal with industrial solutions, and AGIT is our training division. So AGIT is nothing but Access Global Institute of Industrial Training. So where we used to provide training to a lot of in the field of automation and robotics. And Autotech and MX is our manufacturing and logistic divisions, which is located in abroad, UAE. So now let's discuss about robot process automation. So what is robot process automation, or we can say it as RPA? Okay, so RPA is a technology that allows anyone today to configure computer software or a robot to emulate and integrate the actions of a human interacting within digital systems to execute a business process. So RPA robot utilizes a user interface to capture data and manipulate applications just like humans do. So they interpret, trigger responses, and communicate with other systems in order to perform on a vast variety of repetitive tasks. See, to make it better, an RPA robot never sleeps and makes zero mistakes. So when it comes to the RPA, which means robot process automation, the term robot can be a bit misleading. See, we are not talking about physical robots here. Rather than we are talking about software robots, which is capable of automating tedious rules-based activities such as processing invoices, payroll, and procurement. Those are similarities, however. Just like physical robots, or deployed on assembly lines to perform repetitive tasks in manufacturing and production, RPA does the same thing, but in the office. Rather than doing manual physical labor in a factory like physical robots do, robotic process automation boards handle repetitive computer-based clerical tasks such as entering data, ordering supplies, sending, shipping notice, and such. See, these software robots are designed to enable a set of coded commands to communicate with existing systems, replicating what humans would otherwise do manually. Essentially, robot process automation is about training software boards to mimic human actions to perform a sequence of steps at lightning speed with no errors and without breaks. See, in simple terms, RPA is a process of automating business processes. This is achieved using robots to both save on employee time and reduce the risk of human error. So this is what is called RPA, or robot process automation. How RPA differs from other tools? So process automation has been the superhero for industries for a long time. See, if you look at process automation, they use process automation for a long time in industries. Okay, but automation has led to increased efficiency, reduced risk, compliance, maintenance, and enhanced profitability. See, as the technology has made giant strides, RPA has come up and quickly became the new approach to automate business processes while replacing traditional automation. In contrast to other, RPA also allows organization to automate at a fraction of the cost and time previously encountered. RPA is also non-intrusive in nature and leverages the existing infrastructure without causing disruption to underlying systems, which would be difficult and costly to replace also. So this is how RPA differ from other tools. For to be precise, to make it very simple, RPA is very easy to use, and it can be used by the non-techie also. So that's how I can put it in a simple manner. Okay. So the next one is, what is the difference between RPA and traditional automation? So where RPA takes a giant lead. Okay, so in principle, traditional and robotic process automation integrate software to automate business processes. However, there are 5 areas where RPA takes a giant leap from traditional automation. Okay, so the first one is technology base. So what is technology base? In traditional automation, if you see, programming takes the center stage and makes use of APIs and other methods to integrate several systems on one platform. Robot process automation. Okay. But robot process automation comprehends the action of a user at the UI level. For developing traditional automation platforms, a developer needs to have a thorough understanding of the target system. However, in RPA, because the robot is comprehending the actions of a user and is following the steps correctly, the importance and the complexity of the underlying technology and its application takes a backseat. So the second one is vendor or software limitations. So which is vendor is nothing but the client. Okay, there are several reasons which limit the use of traditional automations. Okay, the first one being the customization of the application, integration of different systems, new age and skill developers. Okay, so these things will limit the use of traditional automation. But The automation of legacy systems demand a thorough knowledge of software, and customer will find it very difficult to make any amendments or upgrades. Okay. RPA primarily works on UA layer, user interface layer, and above restrictions will be redundant, making RPI the best alternative. So I hope you all understand these two topics. So the next one is turnaround time. What is turnaround time? So traditional automation demands complex programming and quality test, while RPA offers an easier record and play automation method. See, for example, if you take a traditional automation, uh, the programming would be very complexity, and it cannot be very repetitive. Okay, but while using RPA, it offers a record and play automation method. Like, see, we can uh, have some specific task to be performed at the, so we can make that happen again and again in RPA, whereas it is not possible in traditional automation. Okay. One more thing is RPA is faster than traditional automation. In traditional automation, skilled software developers are needed along with critical IT support. Okay. That's what I told you earlier. So if you take in traditional automation, we need a skilled software, which is IT professionals are required, and not normal IT guy or normal techie guy. He needs to be really skilled enough um, to make this traditional automation works. However, RPA is focused on techno-functional SMEs who can teach the bots. Okay, so RPA is really focused on this platform alone. So this is what is called turnaround time. So next one is customization. Customization. Traditional automation faces critical challenges when it comes to customization. On the other hand, RPA can be tailored easily to meet the demands of a particular user. Uh, see, if you take traditional automation, it is a structure-based thing. Okay, it will come like, if it is has some structure, you have to use the structure in the industry. But if you take RPA, it can be programmed just like whatever the client, or uh, if a particular user wants to customize something which is not available in traditional automation, that gives a big edge to the RPA. Okay, so RPA can integrate various applications like ERP, CRM, calendar, emails, and others to sync information, creating automated replies and to respond for the income incoming mails. Okay, so this is what we can uh, this is what the RPA can be able to done, which uh, traditional automation cannot do. Okay, so the next one is audience. So what is the audience? Traditional automation applications need software developers. See, as I told, this is what we are seeing again and again, right? Um, and this is what I'm telling you again and again, which is traditional automation applications. They required software developers who are adapt with skills and supported by the IT platforms. But in RPA, the traditional automation still find applications in several systems and has its own set of pros and cons. Okay, with RPA, the organization can develop quick, smart, and cost-effective tools to boost efficiency. See, so it will make greater impact and improvement in profits and revenue. So This is what this is the 5 areas where robot process automation takes a giant lead. See, we all know about uh, industrial robotics, right? So industrial robot, so that comes under physical robot. So what does industrial robot means? So industrial robot. So we are talking about the difference between, now we can see the difference between the industrial robot, which is nothing but the physical robot, and this robot process automation. Okay, this robot software automation is completely a software to emulate things in office. Whereas if you take industrial robot is used to perform actions in process industries and manufacturing industries. Okay, so what is industrial robot? Industrial robot is defined as defined by ISO. It is an automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes, which can be either fixed in place or mobile for an use in industrial automation applications. So this is how the ISO defined industrial robot. Okay. So industrial robot always follows 3 laws. So as we all know, if you in many robotic movies, we have seen a lot of robots in movies, right? So in that movies and all, we would have heard a name called Isaac Asimov. Okay, so he's the one who generated the laws of robotics. If there is a robot, if there is a robot, it should have, or it should satisfy these 3 laws. Then alone it can be named as robot. The first one is a robot may not injure a human being. It should not. A robot should not injure a human being through inaction or allow a human being to come to harm. Okay. So the first law is very simple. It should not injure a human being. Whatever the instruction it can be, it should not injure human being at all. So this is the first law it has to obey. The second law being it should obey the orders uh, given to it from the human beings. Okay. For example, whatever the instruction given to the robots from or by the human beings, it has to obey. Where except where such orders should not conflict with the first law, which means if a robot is getting to harm the other things, then it is not considerable. Then it is not valid at all for as a robot. Okay. And the third one is a robot must protect its own existence. This is the third law. So whatever the first and second law, it should obey the first and second law. Okay, as long as it also has to protect its own existence. For example, if the if I'm the user, if I'm giving instruction to robot to move forward where an obstacle is there or a wall is there, if it moves fastly, whatever the speed I'm going to dictate, if it is moving in that speed, it will surely uh, hit the wall or it will damage its own existence. Means it should not do that. It should give us a um, warning signal. Okay, so these, if if a robot or if a machine satisfy these three laws, then it comes under robotics. Okay. So industrial robots timeline. So if you look at the industrial robotics timeline, so it has started in way longer, like in 1954, they have started the first industrial robot, which was introduced by George Dewar. He was considered to be the father of industrial robotics. Okay. And in 1960, they created another robot called Versatran. And in 1962, they created the first industrial robot used by a major manufacturer, General Motors, which is nothing but Unimate. Okay. And in 1973, they introduced Kuka. Okay. Kuka, a famous industrial robotic company. And they introduced first six-axis robot called Famulus. Okay. And in 1974, uh, they introduced industrial robot called Silver Arm, which is used for small parts assembly jobs. And in 1975, they introduced an Asia IRB, which is industrial robotic body, world's first fully electrically driven robot. Okay. And in 1977, Motorman Elton, Escobar's first industrial robot with 5 axes. So these are the major things they used. Okay. And if you're going to consider about industrial robot, you should see a lot of parameters in it. First, degree of freedom. Okay, degree of freedom is truly the same as the number of accesses. Next one is envelope, the region of space a robot can reach. In the working means kinematics. Kinematics means the actual arrangement of rigid numbers and joints in the robot. Next one is payload. Payload is how much weight a robot can lift, which is nothing but a weightlifting capability of a robot. Okay, and the speed. So how fast the robot can position the end of its arm. Next one is acceleration. How quickly an axis can accelerate. Next one is accuracy. How closely a robot can reach a commanded position. Okay. And next one is repeatability. How well the robot will return to a programmed position. Next one is compliance. So measure of the amount in angle or distance that a robot axis will move when a force is applied to it. So these are the robot parameters we are providing. Okay. So if you're going to see if you have to understand about industrial robotics, you have to know about its anatomy. Okay. So what is anatomy means? What are things combined to make it as an industrial robot? First thing is controller. So the controller will act as a brain of industrial robot. Okay. It works as a computer and allows a robot to also be connected to other systems. The program is inputted with the teach pendant to the controller. So we'll be having a teach pendant which has all the access details and other instruction stuffs in it, where we can program and we can transfer the program to the controller. And many of the today's industrial robot use an interface that resembles or is built on Windows OS. Okay, Windows operating system. So we have different kind of operations of a controller. One is limited sequence control. So in limited sequence control, we can place operation using mechanical stops to set positions. Okay. Next one is playback with point-to-point control. So it can record work cycles as a sequence of points, then playback the sequence during program execution. Next one is playback with continuous path control. It is nothing but a greater memory capacity or interpolation capability to execute paths. Okay. Next thing is intelligent control. So intelligent control is exhibit behavior. It exhibits behavior that makes it seems intelligent. For example, it responds to the sensor. For example, if there is a See, in all the, if you take welding robot, the robot will not start to weld unless the safety shutter is closed. So it will not affect the human being. Okay. So in that case, if the shutter is not closed, which is obviously will be having a sensor over there. So it is responding to the sensor. Okay. So that is what we are calling it as intelligent control. So the second major thing in anatomy is manipulator. Manipulator is nothing but the body of what you are seeing in industrial robotic. Okay, so manipulator can vary in size and shape. The industrial robot is a part that positions the end effector. Each of this joints gives a robot another degree of freedom. Okay, many industrial robots in factories or 6-axis robot. So what is 6-axis robot? What is 5-axis robot? What is 3-axis robot? I'll tell you. Okay, each axis provide different motions to the robot. For example, one axis will allows the robot to move forward and backward. Okay, another axis will allows the robot to swing from left to right or 360 degree. Other robot will allow the upper arm of the robot to move from top to bottom. Like this, each axis will possess different, like this, each axis will possess different actions. Okay, so this is what we are calling it as, this is what about manipulators. Okay, in manipulators we are having two different kind of motions available. One is translational motions, another one is rotary motions. Okay, so third anatomy is end effector. End effector is nothing but the connector which is connected to the robot arm and functions as a hand. Okay, this part comes in direct contact with the material of the robot which is manipulating. Some robots are capable of changing end effectors and can be programmed for different set of tasks. For example, in a same robot, if you have seen in the assembly of a car, okay, a same robot will drill, same robot will make a drill. Okay, and it will change its end effector automatically, and it will screw, it will put screw in the same hole where it puts a drill. Okay, so this is what about end effector. And the fourth one is drive. A drive is an engine or a motor that moves the links to the designated position. For example, I told you there would be there are 6-axis robots available, 5-axis robot available, like that I told you, right? So in that, each axis will be will provide different motions, as I said earlier. Okay, so how it is providing different motions, each axis is because it has, for each axis they are having separate, guys, is it audible now?
Yes, sir. It is audible, sir. It is clearly audible.
Okay, 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 thank you. So each, so where are we? Oh yes, we are in drive, right? So this drive, so each axis will possess different, having a separate servo motor uh, to make or to provide different motions. Okay, so those servo motors will be handled or will take evasive actions by these drives. Okay, this industrial robot generally use generally use hydraulic or electrical or pneumatic. But so these hydraulic and pneumatic things, they are not using as of now. They are using only electrical motors to actuate individual joints. Okay, so it is a preferred drive system in today's robots. Whereas if you see about hydraulic drive, they use this hydraulic piston. They use actually right now. I don't think they're using. They used hydraulic pistons and rotary vane actuators, and it is noted for high power and lift capacity. The next one is pneumatic. So pneumatic typically used in smaller robots and simple material transfer applications. Okay, so the final anatomy is sensor. See, I told you already that sensor, through sensor, we can receive feedback about its environment and also a sense of sight and sound. Okay, there are different kinds of sensor available. Vision processes there. Correlate. We can correlate vision with industrial robot, and also we are having physical sensors like proximity sensors available. Uh, so we also can link these kind of sensors to give their feedback, and when how uh, should the robot start, those kind of information the sensor will collect and sends it electronically to the robot controller. Okay, vision sensor also allow a pick and place robot to differentiate item to choose and items to ignore. Okay, so this is the anatomy of robot. So there are five things available, as I told you earlier. One is controller, which is a brain, okay, or a CPU, and the second one is manipulator, third one is end effector, and fourth one is drive, and the last one is sensor. Okay, so these structure will form it as a combinedly we are calling it as an industrial robotic. Next one is types of industrial robot. So there are a lot of types. uh, there are different types of industrial robots available. One is articulated robot, Cartesian robot, polar robots, cylindrical robots, scara robots, delta robots. See, articulated robots. If you take articulated robots, this robot, this robot design features only rotary joints. Okay, so in almost all the industries, they are using articulated robots, which are 6-axis or 7-axis articulated robots. Okay, so each joint is called an axis and provides an additional degree of freedom. Okay, so the links in the arm are connected by rotary joints. So that's how it is going to perform. So this is how the articulated robot is going to perform. Next one is Cartesian robot. These are also called rectilinear or gantry robots. For example, in some cases, we will be using the robots on the roof. Okay, so it will weld from the roof. It will hang in the We'll make it hang in the roof and it will weld from there. Okay, Cartesian robots have three linear joints that use a Cartesian coordinate system XYZ. They also may have an attached wrist to allow for rotational movement. So the three prismatic joints deliver a linear motion along with the axis. Okay, next one is cylindrical robot. The robot has at least one rotary joint at the base and one prismatic joint to connect the links. The rotary joint uses a rotational motion along the joint axis, while the prismatic joint moves in a linear motion. Cylindrical robots operate within a cylindrically shaped work envelope. Okay, so as the name suggests, it will swing 360 degree or 270 degree, depends upon the robotic structure. It will the degree of freedom will allow the manipulator to move from one place to another. Okay, sorry, not from one place to other, from one degree to other degree. Yeah. Next one is polar robots. We can also call polar robots as spherical robots. So in this configuration, the arm is connected to the base with a twisting joint, a combination of two rotary joints and one linear joint. The axis form a polar coordinate system and create a spherical shaped work envelope. Next one is SCARA robot. So these SCARA robots, they get to use commonly in assembly application. Okay, this selectively compliant arm robotic assembly is primarily cylindrical in design. So, which is it features two parallel joints that provide compliance in one selected plane. So, next one is a Delta robot. These spiral-like robots are built from joint parallelograms connected to a common base. The parallelograms move a single EO80 in dome-shaped work area, heavily used in a food and pharmaceutical electronic industries. Okay, so this is the fastest active robots they'll be using in pick and place application. Okay, it works very fastly, so they'll be using this for a I mean, if you want to assemble or if you want to this robot configuration is capable of delicate and precise movement, so we can use it for a small to pick and place small particles, like segregating the different chocolates, or segregating the pharmaceutical things is okay, and pick and placing the or assembling in the phone assembly division. So like this, they are using Delta industrial robot. Okay, so there are different programming languages available for industrial robots. Tasks in plain English, variable assembly language, then Epson or C++, then Inform 3, which is used in Ashko Motoman Robotics, Ashko Robotics, Robo 4th. Like this, there are different program languages available for industrial robots. If you thinking about application where we can use industrial robot application is we can use in all the manufacturing divisions as of now. In future, it's going to be fully made of industrial robotics alone. Okay, so there are different kind of applications available for industrial robotics. For example, if you consider handling operation, it is the most popular application with 38% of the industrial robots worldwide. This includes machine tending, palletizing, various operation for metal machining, plastic molding, etc. So next is robot welding. It is a second popular application. Robot welding, for welding operation in major industries. They are using industrial robot for their welding operation. With 29% of the industrial robots worldwide, they are using industrial robot for welding application. This section mostly includes spot welding, arc welding, and for TIG welding also they are using industrial robotics only. Next is robotic assembly. Okay, this actually robot assembly includes fixing, press fitting, inserting, disassembly. So most of the assembly process was done by a industrial robot only. So next is robotic dispensing. Here we are talking about painting, gluing, applying adhesive sealings, spraying applications. Okay, so in majors, I mean, major things there for painting applications and all. Right now, they are starting to use industrial robot, because we are having a separate robots for painting application. We are having a separate robots for welding application. Okay, we cannot use the same robot for welding and painting application. They are designed exclusively for painting application, and they'll be designing exclusively for welding applications. Next one is processing, robot processing. Processing is not a big segment of industrial robots, and the main application areas are mechanical cutting, laser cutting, water jet cutting. Not all the industries they'll be using industrial robot for this process, but I'll damn sure about this, that they are going to use industrial robotics in all the areas. Okay, in the very near future. So this is how the industrial robotics operates. Okay, coming back to the RPA. So now what we discussed was about industrial robotics, which is nothing but the human or physical robots. Okay, but right now what we are going to discuss is, we are talking about RPA. RPA is a robot process automation, which is nothing but a software which is going to make automation in or automated in business oriented tools. Okay, for example, we already see about RPA and all, right? So how does RPA work? See, RPA is very effective for automating tasks and sequences that execute the same way time after time without variation. Okay, most RPA software companies have a rather intuitive and and pleasing user interface that leverage drag and drop software to build automations. So indeed, RPA software can be thought of as a specific frontier of the no code or low code trend, which means exactly what it sounds like: software that requires little to do nothing in the way of original coding. The idea here is to enable non-programmers, where a business analyst or someone outside of IT, to effectively create software. Okay, in this case, RPA can handle repetitive rules-based computer tasks. RPA robots are capable of mimicking many, if not all, human user actions. They log into application, move files and folders, copy and paste data, fill in forms, extract structured and semi-structured data from documents, scrape browsers, and etc. Okay, so this is how an RPA works. So the next thing what we're going to discuss is what are the process which are relevant to RPA, which is robot process automation. See, essentially, any high volume business rules driven repeatable process qualifies for an automation, right? So we have 5 sectors. Implement fast to achieve ROI fast. Okay, I'll give you an example. A HR service provider from Europe was processing 2,500 sick leave certificates per month with an average handling time of 4 minutes per item. Okay, so it would take for a HR, it would take for a human for to process one sick leave. It will take 4 minutes to process one sick leave. Okay, so they are processing 2,500 sick leaves certificates per month. So within 3 weeks, they implemented an and achieved 90% process automation. The RPA robots extracts data from a transaction in SAP, inserts the information into the customer's system, and prints it. The HR service provider achieved a great return on investment within 6 months, with error rates reduced to 0%, whereas in manual effort reduced to final 5% and processing time reduced by 80%. So it implements very fast, and it is able we can able to achieve ROI very fast. Okay, and the second one also being it can also reduce effort in the back office. For example, um, see, if a retailer, okay, was using its store closing reports to validate closing information for each of its registers across hundreds of stores. Okay, the store's employee used a manual and sluggish process to pull up these reports. By automating the process, the store freed up its employees to now focus on more customer centric activities. The RPA robots now move the closing reports to one server, then read and consolidate the information, the needed information for the store's closing reports. So this is how it reduce effort in the back office, and we are also having it also improve customer service in the front office also. Okay, so trade credit insurance company, uh, it has more than 50,000 clients worldwide. Okay, so they automated the credit limit request underwriting process. So underwriters were previously gathering information manually from internal risk and policy to external, like customer side, Google News sources. With after implementing RPA, they saved nearly 2,440 hours of human work a month. So employee now use the time to work directly with customers to make to make their customers feel worthy enough. Okay, so these are the process or which are relevant to the RPA. See, if you can see the diagram over here, RPA adoption potential through which buyer industry and how it is functioning in industry and functions. Okay, in the top you can see function F&A, procurement, human resource, contact centers, industry specific process, etc. Right? So potential for RPA. See, you can see the colors which are there. You can see the colors over there. One which shows the blue indicates low. From the orange, it shows high. So in banking and financial services, okay, for card activation and for frauds claim discovery, they are using a RPA. Like that, they are using it for different things in different sectors. Okay. So next thing is benefits. So coming to the last thing, benefits of RPA. So as you can see, it would have better accuracy. So what are the, how does it allows better accuracy? Robotic process automation software are programmed to follow rules. Okay, so they never get tired and never makes mistakes. They are compliant and consistent. So it is going to produce a better accuracy, obviously, right? Next one is improved compliance. Once instructed, the RPA robots execute reliably risk or reducing risk. Okay, everything they do is monitored. You have the full control to operate in accordance with the existing regulations and standards. Third one is fast cost saving. See, how does RPA can save the cost? RPA can reduce processing costs by or up to 80%. In less than 12 months, most enterprises already have positive return on investment and potential further accumulative cost reduction can reach 20% in time. Okay. So super scalable. Across business units and geographies, RPA performs a massive amount of operations in parallel from desktop to cloud environments. Okay. Additional robots can be deployed quickly with minimal cost according to workflows and seasonality. See, I forgot to mention one thing. While installing RPA, okay, which means robot process automation, they don't need. We don't have to change the existing thing which they are doing manually. So they are not going to replace any such things. Okay, so so the processing cost will get reduced up to 80%, and within 12 months or within a year, you can able to accumulate cost reduction can reach 20% in time. Okay, so the last thing is increased speed and productivity. So how employees are first employees are able to first appreciate the benefits of RPA as it removes non-value add activities and relieves them from the rising pressure of work. See, for many such things, human may find it difficult. Okay, which I mean, which puts a lot of work pressure on human beings. Whereas after applying RPA in that sector, it automatically relieves the rising pressure of work of a human being. Okay, so the employees are always able to do the value added activities so that they can, which is nothing but concentrating on clients or customers. Okay, client requirements or customer needs, so which improves the or which will improve the business oriented stuff, as well as which will improve the customer to engage with the company much more and even better. To it will make the customer very happy also, right? So these are the benefits of using robot process automation in a business oriented industry. So with that, uh, we have this is what about robot process automation. I hope you have understood the difference between robot process automation and industrial robotics. Okay, so there is a huge differences there. It is entirely different from one industrial robot to the robot process automation. So robot process automation is a completely software oriented device which is used to perform actions inside the office, whereas industrial robot, they used to deal in uh, manufacturing and process industries. And the similarity they both have is they are going to replace the human beings to make it automated in their respective divisions. Okay, so if you have any queries, you can post it on the thing. I can So I have one question from Mr. Vinod. It's like, what will be the maintenance assistance we need in case of robot automation? See, I told you there are, if you're talking about industrial robotics, If you're talking about industrial robotics, see, the maintenance we required, see, it is going to work continuously or 24 by 7 automatically, but we have to provide, it is a machine. It is, we have to provide some rests, right? And we have to check um, the robot service peoples are also there to for the maintenance also. Okay, for the maintenance supports, the robot people will be over there. Know what you're talking about, because if you're talking about industrial robot automation, industrial robotics, or if you are talking about robot RPA. So if you're talking about industrial robotics, the maintenance support, like we have to back up the controller memory. We have to monitor robot in regular motions. Okay, we have to inspect robot. We have to check the cables and its harness. We have to inspect the brake operations of a robot. We have to check the robot repeatability. We have to check or listen for excessive audible vibration and noise. Okay, so these are the preventive maintenance for industrial robots. Uh, so the next question is, an industrial robot to material handling, the pick and place is used. What kind of robot will be used for heavy duty? Yeah. See, in pick and place application, as I told you, depends on the size and shape of a manipulator. You'll be able to pick, or sorry, depends on the payload capacity of a robot. You can choose different robots for heavy duty applications. Also, you'll be using industrial robot for um, for small scale applications. Also, we can use robots. For example, see, I can give you one example. In we are authorized service providers for ESCO Motorman. Okay, ESCO things. So if you consider, for example, um, if you consider the specifications of ESCO robot, okay, the maximum payload capacity of a robot. Payload is nothing but the weightlifting capability of a robot is 900 kg. So it can lift up to 900 kg, the major maximum payload capacity. It varies. We also having a robot which is capable of lifting only 5 kg. So depends on the application, it will vary. Okay, so we are also having we can also use industrial robot for heavy duty applications also. Okay, in pick and place application. So I hope if you are having any doubts, that I have cleared those, and you can follow us on these social platforms. Okay, regularly we'll be posting new videos and technical updates, technical contents in these. You can follow us on these. If you want to have any real-time or hands-on experience, please do visit our offices. We have a head office in Coimbatore, and we have regional office in Chennai, and we have branches in Trichy also. Okay, so you can contact this number if you need further assistance, further support. We are also providing online internship programs as well as online training uh, in this lockdown times. Okay, so if you want anything in that sort, you can contact this number. So thank you guys. Hope I've given you some new ideas on robotic divisions, which is